Security Engineering Manager for Checkpoint Scotland, and this is kind of strange, I think, for all of us, so we'll get this out of the way first. This is the first presentation I have done in person since February 2019, or 2020, sorry, 2020. So it's kind of a bit strange, so thank you for coming along. I know that cybersecurity does feel like the token heavy metal band at a festival just now, where on a Sunday afternoon at 2 o'clock, Law and Order Death are put on, but there is a reason behind this, that we're here and what we're going to talk about. And what we're going to look at is effectively the wider pieces around cybersecurity and what's happening within Fintech. Ray's clicker doesn't work, so I'm going to be try again in a second. But the point is that 15 years ago, we had Minority Report. So Minority Report's a Spielberg film. It's not a particularly good Spielberg film, but it's a Spielberg film nonetheless. But the point in Minority Report isn't about the story, it's about the tech. We got into touchscreen environments in a big way in Minority Report. We have IoT, we have robots, we have retinal scanners, but we also have beacon systems throughout the entire environment that are taking money off people, and that's best played out by Tom Cruise's character going into Gap. In 15 years, that science fiction view of the planet has become a reality. The majority of the things that are available within, other than the retinal scanning, that within Minority Report are part of the wider framework. But where are we? We've got to think about this. We've got to think about the technology we're using, reflecting the art environment we're in. I believe this fully. I think that science fiction is a huge driver for the tech that we've got. I think of our smartphones, it's very Star Trek. But there is an issue with how technology is portrayed in cinema, and this is what we're going to cover. When we go back to the 1970s and Rollerball, we pick up a thematic of loss of data. And it's the first film that really does this, and it's core to the film. Now, I have got a script here and I'm working to it. This is going somewhere. This does turn back to Fintech, please bear with me. But when we look at where we are in terms of the environment that we've built, we take Rollerball at the top, we have data loss, data hidden, and an entire society altered because of that. But as we move forward to where we are just now, we're somewhere between Blade Runner and Soylent Green. So we take Blade Runner, again, seen as one of these sort of, benchmark movies of what the future is going to be like. Interactive adverts, money being transacted in a very different way to how we were doing it in the 1980s. But from there, we then look at the technology strand. It's very analog. Rollerball wasn't. You still have a very analog environment, dial-up phones, those types of things. When we get to Soylent Green, which is based on a novel called Make Room, Make Room, we're in a totally different world. And it's a world of dystopia where tech is held by the elite, money is transacted within the technology, and everyone else is using paper cash. And it's a murder investigation story at its core that turns out a far more sinister review of the planet. But when we're looking at tech, we've got to start thinking about all of these films don't really talk about tech. They show us the interface, but they don't show us the back end. And when we get out to the really clever ones, where we look at Children of Men, again, another very dystopian future, where humans can't produce children. The technology is waning because there's no point in doing tech. But there's still a financial transaction system going on. There's a discussion about what's going to happen to the money, even if we're not here. There's also a discussion within 12 Monkeys around, and this is the cleverest one of them all, it's the most technically advanced. They've created time travel to get over a pandemic, and the only reason I'm including this is I think it's relevant to where we are. One of the things is within 12 Monkeys that there's that analog real world that we live in interfaced with very high-end tech, and that is where we are. When we get to Demolition Man, that takes us slightly further forward, but you can see the drivers here. And the point is behind it that that interface design that I said was poor in Minority Report really is driven by Half-Life, as far as I'm concerned. A phenomenal game, but it's driven a number of interactive services within technology. And by the time we get to think about the interface from the early mid-1990s through to Half-Life Alyx, which is a VR environment, you can walk around in, you can do stuff, you can pick up cans, you can stroke cats, you can open doors. It feels real when you're inside that environment. Is that where we're going? Because this is the opening shot, and while this GIF doesn't, or JPEG doesn't do it justice, you're in a fully immersive environment. Is this where we're going with technology? It's a very William Gibson view of the future where the analog world's reflected in the digital. But that's fine, because what we've actually, the world of engineering is reflecting art. We have the Boston Dynamics built within this environment where effectively robotics, if we look at Chappie and then look at the latest generations of Boston Dynamics, there's no difference. Now, why is this relevant to fintech? Well, it's relevant to a number of different areas. All of these technological developments have seen a huge rise in crime, especially in the last 2 years. And these are targeted attacks. They're targeted against individuals and organizations. They can be governmental. They can be against a private-run company that supplies utility, or against us as individuals. The problem we now face is, if we go back to the Minority Report, this is where all this hoops back, is if we start looking at the cost of this, if we have a Minority Report style environment with fintech where we can interact with a computing system seamlessly and make a transaction, how do we protect against what is now happening, which is cybercrime is going to be 6 trillion this year in terms of costs. Now, what does that actually mean? Right, so we get a billion and a trillion mixed up, but effectively a billion seconds is 32 years, roughly. A trillion seconds is as long as we have been in the continent of Europe as a species. So that's the scale. I can't imagine that amount of money. I would imagine many of the people at the top end of the tree that are very, very rich can't imagine that amount of money. But the point is that at a global economic scale, if cybercrime was a country, its economic output is bigger than Japan's just now in 2019. By the end of this decade, it could exceed America's. This is a fundamental flaw that within a number of different areas that aren't driven by financial technologies, is driven by a lack of cohesive global approach to this ever-increasing problem. Because if we think about the problem itself, it's against the individual. So if you deploy a beacon system which can transact with a card, right? Or a phone, which is real, that exists just now. But you're doing financial transactions via that device. If that device is usurped as an individual, it's feeding into that bottom figure there. The other side is it's not just the individual, it's not just the loss of revenue within, say, a bank account, it's not just the loss of revenue from your employer. It's the fact that the aggregate cumulative effect of this is that the society's ability to cope with this will have to radically alter, because we have to build different legislations. It's not just one industry's problem. It's not a cybersecurity problem. We can help, but we can't fix the underlying problem. That the main trend is you're not going to go to jail for a very long time for committing a digital crime. That has to change. So what can we do in this environment where everything's starting to become interconnected? Our financial environment is starting to become more and more interconnected. I mean, it's, Apple Pay, think about that on your phone as an app. Just as an example, the fact that basically you get contactless in a card that can be skimmed and scanned, how do we help to build a system that not only protects the end user and their finances, but also the organizations that are supplying those services, but a wider framework, start to look at what do we do to the guys that are stealing our money. An example I gave 3 years ago is, if we were to shoot into the centre of Edinburgh in a truck and steal £16 million and then shoot our way back out of central Edinburgh and get away with it, we would be hunted down till we're dead because we had done something horrendous because we stole money. Those types of events now occur on a near monthly basis, and people are, all right, because they're not seeing the tangibility of it in their own lives. But the tangibility in their own lives is the insurances go up. It becomes more difficult to do trade because companies start to get fined by regulators, so on and so forth. So there's a huge impact across the economy. The other side is that there are a number of different reports issued every year, and the global risk landscape for 2021 has infectious diseases now as this leaderboard. This is based on a number of different factors and effectively is the aggregation of a survey of multiple countries. One of the things is with it that basically down in the purple, cyber has always been in that top right-hand quadrant. It's fallen back. But the one that's now been highlighted is the failure of cybersecurity. Now, before it was, if I did this taking my glasses off, It was technical governance failures and IT infrastructure breakdowns were in that right-hand quadrant. So we're starting to see a shift, but we have to think about security at all aspects of what we're doing, whether it's coding, whether it's infrastructure, or whether we're an end user. The other side is threat causality. So while those various things, economic disaster, technical, there's one of them I quite like the name of actually, social cohesion erosion, it's not the greatest slide. But effectively all of those are impacted by the purple, which is IT infrastructure, leading out to finance, utilities, and our day-to-day background environment. And each one has a touch point. So we're now seeing that basically in the analog, this communication system we have is everywhere. It's completely ubiquitous. We wouldn't have got through COVID in the same way. I was speaking to Kira just before this talk started on effectively the experiences in my own family from my grandmother with Spanish flu. They had to go to work because they did mining and they did baking and they did various other group activity jobs. We could keep an economy running by sheltering people. Now, not everyone, because there's still that component, people still need to go out, I'm very aware of that, but if we think about that, that shows how the resilience of the systems are, or the resiliency in the systems that are available, has delivered a kind of different way of dealing with a major, social event. But a failure in that system, and especially a failure in the security model, really is going to start causing a number of issues elsewhere. And where we find ourselves is, if we think about our own, take it back to yourself. I'm going to talk generalities with an exception, but if we think of ourselves and how we interoperate with organisations, just now we have this model. We have a corporate endpoint, this laptop. I'm a home worker, so I've got this laptop at home. But that's living in my network, not my company's network. So we've got to secure it with a VPN, it's got to access SaaS services, so on and so forth. What we'd like you to think about is the number of devices you have in your house that you've bought that connect to your Wi-Fi. So your Alexa, your Apple equivalent, your iPhone, Android, whatever Android device, your Samsung, your smart TV, so on and so forth. All of these are now potential touch points for cybercrime. And I'm not here to be sensationalist, I don't really deal in that, I don't think it's worthwhile, but it's things we need to think about collectively. Because if we take this model here and then think about, I'm running a financial services organisation, you are delivering a digital environment to your end user. I do it with my own bank. I have 2 banking apps. So I've got multi-factor authentication and all those things on it. But having discussions with various different people in finance about what happens if that is usurped, that application is usurped, and then it impacts your environment. There are a number of different areas and a number of different responses, which won't go into in this talk, but all of them are around basically the protection has to be, the organisation has to protect itself from its end user has to protect itself from the service provider. Does that make sense to everyone? We've got to basically start improving the security. So how do we do this as effectively a financial services environment? Well, what we first have to do is look at the current landscape. We've talked in big generalities, things are not great, and they really aren't great. There's a number of issues that are still ongoing. If we look at the SolarWinds event that occurred, that's still an ongoing environment. Don't think that's gone away. That was source code compromisation at a level that if you actually wrote it down, which our organisation did, and then went back to people and said, this is exactly what you need to do, as many other security vendors did, you realise the cleverness and the complexity of what was done to usurp multiple different vendors. This wasn't just about SolarWinds. When you read into it, this is about breaking into multiple systems, not concurrently, but to basically do deflection to one area. This is really bad, but other things are happening. We then need to think about basically, we get to the colonial pipeline. Why is that important? Well, it is important. Colonial pipeline showed up the easy one, which is purely protected, thought through systems that were, in terms of, and by purely thought through, I mean they were perfect for the job they were doing, they shouldn't have had access to the internet, were hit by a ransomware attack. Now, what does this cause? Well, again, you're back to familial level. My wife lives in Virginia, and distance marriage, if anyone's interested, we'll tell you about it later. But the point is that basically fuel supply in the east coast of America was cut 45%. But it's not just for your car or your truck, that was aviation fuel as well. Now, there's a long-tail distribution of these problems that we don't think about. They paid the ransom. This is the wrong thing to do, right? For a number of reasons. This, if you think about If this was analog and somebody threatened you and you gave them money, they'll come back and threaten you again. This is exactly the same model that's followed here. The point is with this, that basically this started to show up where digital into analog becomes a real problem. Now, we haven't seen a wide-scale banking attack. I hope we don't. But there's always that possibility. Because confidence fear, if somebody is the classic one in Die Hard 4, where they basically alter the stock exchange. And it causes panic everywhere. They've got no control over that because they've been used up. They couldn't do what they do in the film in many instances, but the point behind it is turning things off has a financial impact on everyone. The other areas are around the loss of, obviously, things like medical records. These have a value, but just think about it this way. Your banking record and your tax record have a value as well to people. These are not isolated commodity items. These build up a picture of a person as a real person, spending habits, those things, which then can be utilised elsewhere and resold. So you could rebuild from your spending habits a version of yourself that's completely fake. Those types of things do occur. So what do we do with this idea of beacon services and systems? And going back to my interaction in a minority report style environment where I can go up and tap something. And we do that every day and we don't think about it. And we really should think about it. Because you take your device that doesn't have any security on it for about 85% of the population, and you take it up to a scanner and you put it on that scanner, and I'll put money on it that about 60% of those scanners don't have an up-to-date code tree. It's a lot of trust when you're moving money, and there's no analog equivalent of that. That's the weird part. We've just absorbed this and said, oh, that's great. So what we need to think about is our kind of, as things start to expand and more devices in our environment can make a financial transaction on our behalf or on behalf of an organisation without human interaction. That's the other failure in Minority Report. They've got this massive database and there's like two blokes that sit and kind of like have terrible shift life and go in and look at the database and there's going to be a murder. A machine could do that in 10 minutes. You don't need people. That's one of the areas you need to think about automation, to look for alerts, alarms, changes in behaviour, those types of things. The other side is this, right? So you need a standardised model for IoT protection. As an organisation, it may seem, or as a representative of an organisation, it may seem unlikely that you're going to put out something in the field that's going to conduct financial transactions. If you are in that area, and you think about a fridge that can order food, it's exactly that. It's got a tie into a banking service. You need to be able to protect that device. So these areas are high level. These are checkpoint centric for the people in the room. These are pointers to areas to think about when you're developing code, infrastructure, whether it's virtual in AWS, Azure, whether it's in a private cloud, or whether it's tangible physical big boxes. Think about these areas here. First area is about, and this gets bandied around a lot, but machine-led threat prevention. AI is a slightly different thing in my book, but machine-led threat prevention is definitely an area that you want to look at because machines can do the same repetitive tasks a lot faster than us. And that's part of the checkpoint kind of story around basically how we've got really good catch rates. We can identify malware that's new, it's so on and so forth. But other vendors can do this as well. But the point behind it is that that identification through a machine can do one thing that a human can't do, which is the lateral movement. It can pick up on a move of code across a chain of events. And this is all we have really is a chain of events. We have a data service that identifies the user, we have code that serves information to that user, and we have an end application the user interfaces with. Those lateral movement events where a user suddenly decides to try and access 8 or 10 or 15 different services simultaneously is difficult for a human operator to pick up, but a machine can pick that up and go, that's abnormal behavior. Mark's iPhone's never done that before, for example. The other side is around automation of those operations. Going back to that, get the machines to do the hard lifting, get them to do the thinking. One of the core problems with the Internet of Things for me, and it's a specialization for me in Checkpoint, I deal with operational technology and IoT, is you have a myriad of options to buy different things from different vendors. So when you're doing that, make sure that basically they can be interoperated with, they can be reviewed and monitored remotely, and all that data can be pulled back. So you can build up a baseline of what good looks like, irrespective of vendor, irrespective of use, and then from there, when something bad happens, it will alert quicker. Also consolidated security management. Many of us, and having worked in industry prior to coming to a vendor, customer in the public sector and customer in the private sector security vendors, one of the problems is the basically centralized management. We have all these different huge systems that do really cool, clever things, but how do you interface with it? How do you interoperate with it? Maybe that's one bit in Minority Report, even though the interface is horrible in my book, is that effectively everything's centralized. Think about that as well. Also, too many devices and protocols, what do you do? So you have to conduct, irrespective of what industry it is, but Fintech, this is actually quite vital. Know what's connected to your network. Know that those IoT devices are plugged in, whether they're cameras, whether they're beacon systems, whether they're financial transaction points, whatever they are, tills. Make sure you know where they are. Make sure they're segmented off from the networks. And also look at effectively the fact that if somebody plugs something new in, you can identify and classify this and then bring it back. This is only about half the story that we're going to do in the next part about the back end that I discussed earlier. Get detail in each of the devices, irrespective of what vendor it is. Go in, look at the IoT components, see what it's doing, see what it is. It will have a risk score associated with it because many are built by lowest bidding vendors or code trains that have been used to develop them are out of date. Those can be fixed retrospectively with an enhanced security model. However, you do need to know that you've got the issue. So the checkpoint approach to this, and this is the only time I'll do a vendor-specific slide, is this area here. We can deliver effectively security across the physical appliance-led layer or environment for IoT, but we can also go a bit further, which is IoT nano agent, which is on device. If your organization's considering building these types of devices, we can put a nano agent in, and the nano agent will basically tell you what's wrong with the device. It will then, when it's in operation in the field, so you can fix your code train before it gets launched, when it's in the field, the nano agent will look at good behavior. It will then say this device is doing something very, very irregular, and it can be automatically shut down if you choose to set those parameters. So quite powerful set of tools, but these are areas I would want people to think about. Across the entire environment, whether you're in a public cloud environment, private cloud, or physical analog environment as well. Just now, we can supply protection for these types of services, and that ranges from the delivery of water through to effectively the most high-end esoteric IoT environments that are sharing data about a user's movements, users' transactions with the actual physical environment. So device to data centers, that's great. We can secure all that stuff, and we've been doing that for a long time as a company, but what do we do in the data center? So the data center that you build with IoT generally becomes hybridized. You have physical devices in the field, you have logical devices inside the data center if we take a public cloud model. And from there, we would recommend that you look at a number of different areas. One of the areas is about prevention at the edge, that idea of being able to cut it down before it gets in. That's pretty key, whether it's a remote home user, whether it's somebody in the field with their phone, whether it's the device itself. It's just containing the threat is number one by preventing at the edge. The other side is the workload and container security. The code trains that are built need to be reviewed. We can't go in faith. There's a lot of really, really good DevOps people. They do some really good stuff, but there's also, and having worked in coding at one partner here, there's also that copy and paste moment for people as well. That does happen, and that's fine, but we need to think about that, and then basically how do we secure that? So looking at the workload within a virtual server environment, we're back out, looking at the container, runtime container with Docker, for example, looking at the security around those. And then looking at the application security, that feed that's coming back out to the end user. So the API call, maybe that's going out to another organization, securing an entire supply chain infrastructure as well through application security. And these areas here, I think, are the bits that we need to then again consider, right? So these are checkpoint-centric slides, but you have to look at the highest security effectiveness. What's right for your environment? That's one thing that I would stipulate to everyone is that while I do work for a security vendor, there are other security vendors, the security's got to be right for you. But by following this model of effectively containerization, monitoring and management, and then looking at this against the background of if we get this event, what can we do and how good is the other security models around it? this kind of starts to tie everything back together. Now, in a checkpoint environment, we have 100% block rate. There's a number of reasons behind that, but the point is with it, the block rates are based around standardized testing of a number of different variants of malware, a number of different security attempts against the devices. There should be a threat prevention engine from any security vendor, which is, at its crudest level, a catalogue of known events. Now, within that, that's fine, but people go off and build new things. You know, DevOps people are clever. Cybercriminal DevOps people are clever. They go off and build new stuff. So you have to have a system that basically is adaptive to those changes and can identify a new code train that's malicious. And a number of other areas here around vulnerability scanning, especially within code trains. Those are things I'm quite passionate about, because a number of times I've seen devices where if they had looked at the code when it was built, they probably wouldn't have had the problems when it was installed. Those types of, there's a number of CCTV newspaper headlines from last year, which when you actually drill into it, there was a number of known vulnerabilities within one of the code trains. If that hadn't been injected into the system, they don't have those problems. If we take that back in, there's also liability, because if you're buying things, think about this again, you're back to that idea of an insurance environment. If you're fielding something you know isn't working properly, who's liable? Is it the user, is it you? So there's a number of things there that we need to consider as well. And then behind that, the checkpoint system has a vast real-time threat intelligence database, which then takes other feeds in and feeds it out. So think about that when you're building these security models out. The other areas are within the data center itself. If an IoT device is compromised, and I have seen this, the data coming out of this animation is, yes, you build a sub-policy for access. That's great, but the point behind it is be as segmented as you can be in all facets of your infrastructure. And from there as well, think about that software-defined environment, you know, service chaining, how things are tied together, you know, how the different applications you're building and using to serve this data back and what it's transacting back into, whether it's a banking database system, whether it's an e-commerce platform that's got, you know, PCI environment as well. Think about that the other way coming back in. Think about the supply chain to you and you to the supply chain, and how do you protect yourself? One of the things outside of SolarWinds that I've had to deal with in a number of different environments is trusted supplier to an organization X has a security event, but the security is different for the trusted supplier than it is for the untrusted supplier. Don't do that, make it the same. Because that's, you know, it's that civil service thing in the HMRC of basically believe but verify, I'm afraid. You need to think about, you know, anything that's accessing your service has to be as secure as somebody that's randomly accessing your service. And a unified policy, so the workload protection, the network threat prevention, the posture management, think about basically the overall security posture. So these are checkpoint products, but the concept is there, which is a unified policy. So from the IoT, from the end user, me using the application of that beacon, you know, scanning my phone against a finance device, through to basically your own infrastructure, and then the code coming back out to other systems. Look at all these things and think about your posture management. Think about, is this the right security model for our organisation? Does it need enhanced? And, you know, think about prevention at the edge, isolation, automation, and also what to take in, but all of these different devices, services, systems, they need to be looked at, and then basically have a checklist, make sure it's done, make sure that the, you know, the solution you put in is scalable, because if you hit great fortune and the company takes off, then you've got to make sure that that's a replicable model as well. So if you are going down this route with IoT, these are the top 5 things I would think to do in terms of a very basic security model. There's more to it than this, but the idea with this is that effectively prevention at the edge, and then thinking about, as we're going back to that idea of know what's in your network, know how to control it, and then basically know how to protect it if you have a malicious event. That's the start with that edge. And so thank you very much, everyone. That was quite enjoyable. Thank you for your time. Does anyone have any questions?